Um, Welcome. So the topic today is navigating complexity in microservices and distributed architectures. So I guess everybody here is either experienced that or about to experience that, or aware that it's something that you could experience. You start off in a world where you've got a lovely little monolith and it's all going fine, and then you want to scale for one reason or another, or you want more resilience. So you start creating a distributed architecture, and that's not a free ride. As you get more things, you've got more overhead, and that becomes more complex to manage. So today's session is going to be a panel discussion. We've got four software professionals here today who are going to offer their views and opinions and thoughts on the topic. I'm going to be your host. So the plan is I'll do some introductions. We'll go around. I've got some questions prepared. So we'll go around and ask those questions. At the end, if there's time, hopefully there will be, we can open up the Q&A and offer any of those questions there. If you have any thoughts as the conversation's going, if I remember and I spot them and they're kind of relevant, I might chuck those in as well, just for a bit of interest. So probably the first thing to do is start going around with introductions. I'm Andy Weir, software engineer at HeadForwards. I've been with HeadForwards for 12 years now, been involved in making software for about 20 years. So that's me. Next, if we go to John, just because he's at the top of my screen.
Lucky me. So some of you probably know me because there's quite a few HeadForwards people on here. For those who don't, I'm John Howell. I've worked in IT for 25 years in several different industries, a chunk of that in travel and finance. And during that time, I've designed and built a load of different systems in different domains in various languages. Some of those have been monoliths, some of those have been microservices. So this is a topic that I find very interesting.
Cool. If we go for DDR next, you're next on my screen.
Hi, I'm Daniel Deruvo, best known as DDR in HeadForwards. So I've been with HeadForwards for almost as long as you, Andy, about 11 and a half years. And my experience also spans about 20, as a software developer, so spans for about 20 years. In one of the most recent projects I've been working on in the last actually few years, quite a while now, it was the migration of an application that was a small part of monolithic system into a microservices architecture. So hopefully I'll be able to give you an insight as a backend developer on that experience that I had.
Awesome, thank you. Chris, you're next up. You're next on my screen.
Yep. Hello, I'm Chris. I did work at HeadForwards for a very long time, seven years, I think. But now I work at NTT as a principal software architect. I've also recently been involved in a company called 4-3, which work in banking industry as a product owner for the IT operations side of the business. And whilst at HeadForwards, I was a solution architect and agile facilitator. So actually, I worked a lot with the teams who were building and developing the platforms and microservices, and looking at the architecture and the governance around how we manage that. And DDR had the absolute pleasure of taking some of our platform and building on top of that to make its microservices suite. That's it.
Cool, thanks, Chris. And last but not least, Gary.
So good evening, everyone. So myself, Gauri Shankar, been with HeadForwards pretty much almost 8+ years now. So I worked on different projects from HeadForwards and also outside the HeadForwards. I worked on different companies like e-commerce, health, government, financial, banking, pretty much all the sectors, and also worked on various environments and departments like automation, manual, release, test manager kind of thing. Yeah, so with 18+ years of experience overall in QA industry, that's me.
Awesome, thanks. So onto the questions. And the first one's kind of really a bit of a warm up question, and then we'll kind of dig into some depth. So the topic is managing complexity or navigating complexity. So probably the first question to ask is what kind of complexity or challenges have you faced? And the other side to that question is, it, like I said, it's not a free ride having a distributed architecture. It gets you inflict complexity on yourself. So what was the driving force that got you where you were kind of facing this complexity? If we go from top to bottom again, so if we start with John again.
Yeah. Okay. So I think for me, complexity, you inevitably, if you've got lots of complexity, people make mistakes and systems break. And I think if you have a lot of complexity and the system is tightly coupled, then you end up with cascade failures. You get systems break in ways you didn't expect. And I think although decoupling your architecture creates some complexity, it gives you this ability to have a bit fail in isolation. And if you then cluster that whole system out, then you can build something that's resilient to failure. Whereas I think if you couple the whole thing up, unless you can keep it really simple, you run the risk that you're going to get these cascade failures. And inevitably software is complicated, so you're almost guaranteed that someone's going to make a mistake. And I think the other advantage is it helps you keep, you can say this piece over here is this service and these people know about it. And so it's quite clear where those boundaries are. I think those are the advantages. But you're absolutely right, it is a bit more complex. You just have to use systems to manage them.
Oh, I'm sorry, just scribbling the notes down there. So DDR, you're up next, and then we'll go that order. And don't worry, Gary, you'll be up first next time around.
Yeah. So the main driver, I think, for our client in this project I was involved to adopt a microservice architecture was to break away from a massive system that was very difficult. It depends on a lot of other teams, and things like deployments were very complicated. There's a lot of red tape, took ages to get the software shipped. And in this particular case, they had already, in a different part of the company, they had already experimented with it as microservice architecture, and they already had a good experience with that. In terms of challenges, well, the approach we took was to migrate features of this of the old system, the monolithic system, one by one, and replace it with microservices. And at the beginning, it was quite challenging because we had to first implement like the synchronization between all the new system, and then you have we had to maintain two systems at the same time for a while. And then, well, you have an increased complexity. You have more moving parts everywhere, as we were discussing. So things like debugging can be quite challenging. You have to see. You have to go and get logs of many components, many systems, many microservices. Things like building just maintaining a development environment locally. At the beginning, we it was small enough that we could manage it, but at some point, when you start adding more microservices, more complexity, it becomes really hard. So you have to come up with other solutions, like having integrated environments and things like that. I think I'll give you quite a few.
Cool. Yeah, no, that was a good cover of the topics. Chris, you're up next. So question for you.
Yeah, absolutely. So, well, the main driver of distributed architecture really is stability, because splitting things into the smallest possible component within a subject domain or a specialist domain makes absolute sense. So you can divide the way that the teams that develop that, the teams that own it, and you sort of release trains out so that you can release components as easily as quickly as you're able to without affecting others. So you've got the the evolution of your overall platform or services together is really quick. And if there's a problem with one, it doesn't affect the others. I mean, that's always the key driver. Challenges in that, many. I mean, as Didier mentioned, when you start to or when you're unable to develop sort of loosely coupled dependencies between these services, debugging is very, very difficult. One of the advantages of distributed services and microservices is you can pick the best technology stack that you want to use, or the best technology for the database types, whatever it is, to deliver the service that you want to. That's sort of the polyglot model. But the flip side of that is that as people move and teams move around, you need such a wide breadth of knowledge and expertise to support and maintain those types of environments. Working with that, sharing that knowledge is incredibly hard. I think we'll touch on governance later, but that's my experience. Yeah.
That inverse Conway, isn't it? HR designs your architecture. So finally, on to you, Gary. So what's it look like from a tester's eye view?
Yeah, there's equal pros and cons. Having architecture like microservices, and basically because of this multiple microservices, testing the individual components will be much easier. But constant change in the application, sometimes regression testing gonna be like the most complex thing. So when it comes to an individual factor, it is easy. Just we can test that particular one, can deploy it fine. But the impact on the new applications or new services keep on adding. The regression test is the one key area where you have to focus more. So that will be definitely, it's going to be a very complex thing. But there is now we got a lot of tools where we can automate the things, where you don't have to go and test every time you make any changes. Just run the automation suites, and obviously it will do the testing and it will show the results. If something fails, it has to be when we initially started, the test used to be flaky and they used to fail for no reason. But nowadays, we got a very robust frameworks where you can make sure that tests are failing for a right and genuine reason. So yeah, my opinion is it's both plus and minus we got.
Cool, thanks. So that's kind of the start of the 10. The next question I kind of had was, what part do libraries or tools or strategies or governments or kind of, I know that Agile Manifesto says individuals and interactions over processes and tools, but you kind of need that automation and tooling, I think. So maybe back to you, Gary. It's kind of maybe.
Yeah, you're coming from the reverse order this time. No, I'm not ready. Yeah, so basically, I mean, what kind of tooling? Basically, it completely depends on the type of application you're working. We can't use the same tool for every application. So instead, rather than I'm saying like tooling, I would say like, planning in advance, I would say like, you need to involve as a testing department. You should be with the development team, and you should be with the plan. I mean, what is it called, BS, to understand the application well in advance. So, you can come up with scenarios which could affect the application. When you make some changes to, some X part of the application, you should be able to analyze and, think in advance, what kind of effect this will be on the other part of the service. So these kinds of things can be done as a tester, being involved in the early stages. So coming to the tooling wise, today there are multiple tools, and they're coming up with specified tool for every application. That's a most complex thing now. If you come with Dynamics 365, they're coming with Easy Repro or Excel Q, or a couple of things will work for them, and not everything. And coming to some other applications, only few tools will be working. So you should be able to adopt. Adaptation is one more thing. If you are familiar with some kind of application, you should be able to easily adapt to the new changes. So yeah, involving in the early stages would be the best thing. That's my opinion.
Cool, thanks, Gary. And then the same question to you, Chris.
Yeah, I mean, I've focused more around sort of the governance and experience, if that's okay. And the so what's really interesting, certainly when you've got multiple teams and multiple microservices delivering an API, RESTful API platform, actually the standard specification and governance becomes really important. So there may be policies around security and identity management that need to be implemented by all teams, and they need to be done in a common way. That compliance is important, and you need to ensure that policies are enforced, and you're able to test for that. But even something as simple as I remember one of the clients of our APIs and another internal team that was going to consume them said to us, well, it's really obvious that as you move between the estates, you can tell different teams have worked on them because of the slightly different ways that the APIs respond. The slightly different standards that they may use. You'd expect a standard around pagination, for example, and that might be implemented slightly differently on different endpoints. So, having a guild almost of agreement between the teams that are certainly delivering the common platform is a really important thing. And yes, that goes to sort of interactions and a shared understanding, but also documentation around that is really important as well.
Awesome. Cattle, not pets. Okay, so over to you, Didier. And same question again, is kind of what kind of tooling or processes or strategies help deal with that complexity?
Yeah, so when you adopt a microservices architecture, you have to adopt some tools are essential. Things like you probably need a container orchestration tool, something I suppose a gold standard in this is something like Kubernetes. But then you need tools to help you have consistency between different environments, for example. I think probably Helm, something like Helm charts would help you with that nowadays. Then, in my experience, one thing I enjoyed, I suppose, working with was we had a nice set of in-house developed tools that allowed to do things like accessing shared services and standardizing a few things. So we got everything in a single place, like a command line interface tool. On things probably like having maybe microservices or even Kubernetes object templates with that sort of force the rules and the conventions you have adopted can help you.
Cool, thanks. So, loads of automation and documentation's code.
Yeah.
And again, same questions to you, John, if there's anything left.
Yeah, well, I mean, I would agree with everything that's been said, and actually that covers most of it. I think if I was going to summarize, I think essentially what you get when you go to microservices is a bunch of complexity that you don't obviously have when you build a monolith, but I think you kind of do. It's just you don't realize about it yet. And I think if you do what these guys have just said, then what you're doing is managing a whole load of that complexity, because if you have the right tooling and you have the right governance, then a lot of what appears to be complexity in microservices becomes an advantage. So the fact you have lots of small things then becomes your advantage. If you have to try and think about that in your brain because you don't have the tooling, then it's too hard. But because you can have this sort of consistent cadence and this consistent delivery in a nice system where everything's containerized and treated the same, then you've got something that, while it appears complex, in fact is much more simple. And that's when you win, I think.
Yeah, definitely. So my next question is kind of flip it on its head. So we've kind of touched on it a little bit, is that people are involved as well. If you've got lots of things, you've either got lots of people who've got to interact with each other with lots of things, or communicate the protocols between the things. Where does kind of people and communication come into the topic, and is that, I'm sure it is, I'm sure that's what the answer is going to be, is that part of the complexity as well. It's not just the code and the deployments and all that kind of software stuff. There's like all the humans involved as well. I don't know, maybe start with, if I go to Chris first. I haven't planned what to do after the second question, so I'll start with Chris.
I'm going to be talking about people from the perspective. Yeah, I mean, you touched on Conway's law earlier. I mean, I'm sure many people here have been spending time with Mr. Gervin would have heard of Conway's law, which basically suggests that software architecture and systems modeling follow the communication channels that an organization and structure has, basically. So it's very easy to find stuff being developed by teams that have capacity to do it. They may not necessarily be in the best place or the best experts with a particular technology stack to do so, but that's the way it is. It is hardest thing. I mean, so one of the nice things that a micro application service architecture would give you is you've got a very small domain, and you are empowered to do what you need to do to deliver value. So that is, release. You own everything from start to finish. So instantly, you're as a developer, you're involved at the start of the conversations. You're hearing what the business needs, why the business needs it, what's it want to do. You can affect the requirements of the user stories as they come in. You develop, you demo, you refine, you test, you release in your chain. Nowhere in that is you define the rules within your teams, and you own them. So when DDR mentioned sort of the monolith architecture and the number of people who are involved in the release chain there, of course you've got compliance and governance in there too. So when you're making a change, if you're using sort of Item 3 type change policies, you've got management, and you go through notification and governance and a change advisory board. Unfortunately, a lot of people still think it's a change authorization board, so you end up sort of putting this work down. You can't get it out quickly, you can't see the value, you can't fix things, you can't iterate quickly. But as part of that becomes trust. You need to earn the trust of your clients. So and you're certainly the people that look after governance in your organization. So I mean, I agree for very nicely defined sort of a standard change, which is the process of making the change, not necessarily the content of it. So provided you've got a standard and common way of making a change in a way that's not going to affect the availability of the system, and you're confident with the testing around it as a team, then you're empowered to do it, and you automate that sort of release management and the notes and everything that goes with it. I've always used the mindset of the Friday 4:30 release window with a team. In essence, it doesn't matter that it's 4:30 on a Friday, and if you feel something's good enough to release and you are happy and confident with it, then go ahead and do it. And then you just apply that level of uncertainty every other time you want to release. So it is a change. You're not sort of passing over. And I'm sorry to Gary on the call. You're not passing the responsibility to testers to pick this stuff up. You own that within the team. It's not just one person or one particular role that does that.
Cool, thanks. And then Gary, if we go to you next.
So I agree with Chris. Basically, it's not just a tester's role always, just especially in the environments like, microservices, where you can deploy when and where you want it to deploy. And mainly, it can be deployed anywhere in the world. It has got potential to deploy across multiple geographical locations. So I would say unit testing plays a key role here, especially in these kinds of, because I'm a testing background, I always, it doesn't matter how many questions you ask, I'll again come up with answers related to testing. So I would say, so the challenges basically is microservices. If you can come up with more unit testing, having a communication between the testing team and the development team and everybody involving, even at the stage of unit testing, that would be a good place, where you can mitigate the, delays, especially at the time of deployment, at the time of releases. You can't just, let it go on to the last minute. So we are providing a certain amount of time for someone to come and do the testing. So it's completely understanding between the teams. Okay, this is when it's been deployed, so let's do the unit testing. So we are happy that 80% of the testing is done at the stage of unit level. So now all you need to do is make sure integration between the applications are working fine, and running some automation tests and some expert testing. So yeah, that's me.
Yeah, thanks. You want it to be a really frustrating job for a tester, finding the things that are wrong, not fish in a barrel. So if we go to John next.
Yeah. So I had an answer to this question. Unfortunately, Chris has pretty much said the same thing. So I'm gonna build on that. I think yeah. So I think what it allows you to do is give the team control of the system and ask them to write an SLA, ask them to manage all of the processes that sit around that in an ITIL style, and it allows you to say, well, these changes are standard, and you don't, I guess it's about ownership, right? You built it, you run it, all of these things are your problem, and here is the API you define, and this is the SLA you provide. And as long as you can keep doing those things, then you can get on with it. And it sort of means that you're breaking the service down around the team, which is quite agile, with or without a capital A.
Yeah, capital A is evil now, isn't it? We're only allowed to have a lowercase a agile.
That feels like process over people language, is specifying you're not allowed to capital A. I feel like this is probably a place where I could get stoned, so I'm going to stop talking.
So last but not least, Didier, if you've got anything left that everyone else hasn't stolen your thunder, people managing people complexities.
Yeah, well, so I mean, I'll start with one advantage of having a microservice architecture. It's like so each team, in theory, can define their own stack and their own rules, and but then that generates some complexity, because you see things like the same problem gets fixed many times in different ways, or if every team applies domain-driven design to solve a problem, then I came across things like the same entity had 5 different names in different microservices. Yeah. I guess in terms of people, one thing I wanted to say is there's always someone who's very passionate and sort of like a true believer in your team. They tend to be the younger members, and I think it's useful to harness that energy and make them evangelizers of a microservice architecture in your organization, if you can.
Cool. Yeah, definitely. So the next one is a bit of a confessional. So we've got the next couple of questions are kind of successes and failures, or failures and successes. We'll finish on a high. So kind of the next question is, what are some pitfalls you've fallen down the pit of despair, and how did you deal with it? So start with DDR.
Yeah, some pitfalls. Well, I think sometimes we can have a tendency to over-engineer things. Sometimes you need like very complex microservices, and then there's this temptation to copy it when you create a new one, and then you maybe it's probably maybe bringing all the bells and whistles you may not need in different microservices, different problem. Yeah, and I think another thing I found is that for example, I've seen we've done pretty good job in implementing unit tests, for example, but then you can over rely on the unit tests, and maybe overlook the integration tests and regression tests. So yeah, when you adopt a microservice architecture like this, you obviously unit tests are essential, but manual tests are are not as important, but they're still needed, still important.
Yeah, thanks. Yeah, I think I always think when you've got an architecture diagram, everybody focuses on the box on the architecture diagram, and a load of the fun stuff happens in the line that goes between the two.
Yeah.
If we go to Gary next.
Yep. So difficulties and pitfalls, you said, like, right? Yeah. So I mean, at the microservices level, the most difficult thing I would say, or pitfall, is like, testing the global applications where the networking is, you can't actually measure the way it is working in all the locations. You need to have all the servers to test these kinds of applications, but which is practically not possible in microservices, because when it is spread across multiple locations, you will never be able to get the accurate results. Sometimes there will be a high network traffic flow, and if you, especially at the time of performance testing, you can't get the accurate results. It has to be like, you have to run multiple times to make sure, okay, at this given point of time on a particular day, what kind of results are you getting, and you have to compare it multiple times. So that is the one thing which is, I believe, is like difficulty with microservices testing.
Oh yeah, just dealing with the sheer size and distribution. Chris, let's go for you next.
I've got 25 minutes, so I can probably fill that with a number of pitfalls and things that I've gone wrong over the years. Just thinking recently, so that the easiest trap to fall into actually is losing the loose coupling between services, and certainly as systems evolve and grow over time. Only this week tripped over a scenario where the platform, which is a series of microservices delivered over microservices and functions. We talked about containers and container orchestration quite a bit, but actually you don't have to use that technology. Serverless functions are very, very powerful, very quick to work with, and deliver the same abilities. But we're in a scenario where we have 3 or 4 different teams all around the planet developing the services. All of a sudden we find we have a dependency on one particular service, one particular endpoint, which itself is made up of multiple components. When that does not perform optimally, you suddenly discover that large chunks that you thought were completely independent fall over. And that goes then to observation and monitoring. And if you're using multiple technology stacks, multiple locations, correlating those events and information is really hard, and that can lead to a long recovery time potentially. And you need lots of experts and people all over the place to be able to really pull that together. How do we deal with them? Well, yeah, good question. There's certainly many tools now, and as clouds have evolved, people are working multi-cloud now. But as clouds have evolved, you've got more tools natively available to you to capture logs and to analyze, and the advancement with the AI tools as well will help you spot patterns, or spot patterns for you in the logs, so you can sort of proactively try to capture some of the issues that you have. Well, just on the flip side, away from the technology a bit, certainly when you've got great teams producing services very quickly around a particular business problem, you're there to solve, well, most of the time you're there to solve business problems. But you can implement something quickly and get it out, but the business may not be ready to adopt it, and certainly maybe wanting to evolve as well. And the evolution and managing that can be quite hard. Once you start to build up the logic and the business debt on the services, there's no easy way to maintain that velocity sometimes in delivery. So taking is not just a technical journey; it's a business journey as well. Agility within the business, within the organizational setup, the mindset, and different parts of it all come into play in that, and that's certainly takes a level of management. Or the M word, not with a small m.
Yeah, definitely experienced the write your things ready. Can we not wait for next month now? No, we need to get that out there. We built it. It's where things like feature flags come in, isn't it? If you can be on that page with that.
Exactly that. Yeah.
So I think if my memory is correct, John, you are the last answer. Hopefully my memory is correct.
Yes, I am. So I think most of the big pitfalls are either, as Chris says, you end up tightly coupling something when you didn't mean to, or you end up introducing complexity for no reason because it's cool or because you think that you should. Which a couple of examples that might be making your services really small, but for no good reason. That I've seen that done. I've probably done it myself. Premature optimization, which is the same problem everyone always has in all software, where you over engineer the thing for the problem you don't need to solve. And in this case, I think that tends to be, the tooling or the integration layers. I've seen people use really complicated service fabrics when in fact there's only a few services, and you think, well, why did you bother? Or in one example, I've seen a service fabric used where there are only 2 services on the end of it. And in fact, all it did was make life more complicated. And the other, I guess, something that is unique to microservices is you can get failure conditions because you didn't properly understand the relationship between all the services. So you think it's resilient, but in fact it's not. I've definitely seen people build clustered or microservice environments where they think they're more resilient, but in fact they're less resilient because they haven't understood how the system fails. And I think some of that stuff can be harder to understand. How do you solve it? I think you just need good teamwork, and you need to really think about what you're doing with a bit more. You've got to think about the different dimensions of the problem rather than just go with it. Certainly AI tooling can probably help. Good pictures help.
Everyone loves a diagram.
Absolutely. It can't beat a good picture.
Cool. So we've got one more question left. I'm just going to flag up if anybody that's listening that hasn't got their face on the screen wants to ask a question, either chuck it in the chat or the Q&A, and I'll pick them up. But the last question I've got is like the winning at microservices. What are some successes, and what did you attribute to them? Did you kind of plan for it, or did it just kind of happen? You think, well, that worked out well, let's do that again. If we reverse the order, see if I can reverse the order and try and remember. So, John, if you go up first.
Obviously, it was always planned. We never do anything in an unplanned fashion. It's always down to our excellent planning, but it goes well. I think when you do it right, you end up with a system that's actually more simple than it should be, because the tooling runs and the system runs. And you, as Chris said, you can release something whenever you want because it doesn't matter if it falls over because it will still run. And you can lose 2 or 3 servers and put your feet up and not care. That's the nirvana, isn't it? Have we ever got there? Probably not in all of those dimensions. But I think that's because, given a great infinite resource, you'd get there, but resource is always constrained. So. But I think you can always strive to get to that place. And I think, if you think back, some of us will probably remember running, on a Windows NT machine in the cupboard, and those sort of things were painful, and you end up having to write a lot of the code yourself. And where we are now, you can throw a container to your Kubernetes environment and say, here, run that in 5 places in different places in the world, and that's quite progressive.
How old do you have to be to remember running NT4 in a cupboard?
Well, so I'm nearly 45, so I don't know if I'm old enough. Well, I'm definitely old enough, but I don't know how old you have to be. I am old enough, yeah. I have distinct memories of rebooting the NT4 domain controller on Friday and thinking it would be fine, and I didn't go to the pub. It was 4 o'clock on Saturday morning before that was fixed.
Yeah. Cool. So, whether you have or haven't run an NT server in your cupboard, Chris, what are some successes you've experienced?
I was thinking I had 351 running. So I had a couple of years on you there, John. Sorry. So distributed microservice architecture and good tooling and pipelining. I mean, I love telling the story of sitting down with one of the senior architects of the client, and he's really frustrated, desperately needed to get some data from one of our microservices into his application. He said, can you add this filter? We want this additional attribute in there. And I'm like, yep, sure. Let me write that up. So on a card, sat with the developer. It was written, tested, went through all our processes, our governance, unit tests, integration tests, release notes, validation on the staging environment, integration environment, and out into production. He was thinking, well, that's going to, it must have taken you what, 2.5 weeks to sort that out. 46 minutes end to end, and you have the right people, the right tooling, the right mindset. It's all possible, and that's not blind luck. That's an awful lot of work and mistakes along the way. 3 or 4 years to it, and success. Personally with the team, I mean, it's just that absolute passion and thirst to adopt the new technology. So it's not just the young people that want to do that. Making those mistakes and over engineering, as John mentioned, it's very to pick the new shiny stuff, but actually find the value for it in your stream. Learn from it, see where the overall mindset is shifting you. As a technology expert, because it's not just coding development. There's so much of it now. Keep reading, keep learning, keep listening. I think
that's right, and I also think if you look at the monolith version, you couldn't do what Chris has just said. Zero risk. It's not feasible to do that at scale.
No. Well, I mean, this application stack was running in multiple places around the planet as well. So we were pushing out everywhere. But it was possible to do that.
I think it's game changing in terms of little A agile as well, isn't it? If you can, make a small change that quickly, you don't get the product people picking up everything they can possibly think of to send to you, because when you get your shot at development, you're not going to get another shot for another year. So you better make sure you list everything you want to that other end. So like, what do you want today? Oh, I wouldn't listen. There you go.
Yeah, well, exactly. Yeah, if the request makes sense and you happen to be there and you've got the capacity to do it. Just do it. And that comes through simplicity. Those layers, the simple interfaces on top.
Cool. So DDR, same question to you. Some successes, what are you celebrating in microservices or architectural world?
Yeah, I suppose major the biggest win is to reduce dependency with other teams or the parts of the organization. Like it could be in terms of your changes doesn't have to go together with other teams' changes. It can be in terms of testing. I mean, you develop a small change, you don't have to test regression test a whole massive application. Microservice architecture works very well with continuous delivery, continuous integration. Thing in one project that was involved in, I can't remember the expected time to get something released in the monolithic application, the monolithic application we migrated was something like more than a week. And then with this, one of the most active points of developing this microservice architecture, we managed something like 25 releases in a day for a corporate. Like and then we experienced like less fault tolerance, less. When something goes down, not everything goes. Not necessarily everything goes. Yeah.
Cool. Thank you, DDR. And then last but not least, Gary, I think that you're the last one up, aren't you?
Yeah. It's like when there is like multiple technologies and multiple languages are involved, there is always chances of learning new things. It's about pairing with the right people can always be an additional advantage. For developers, for testers, so you'll be constantly working on new stuff. It's not something like on a perfect day you'll be working on one application, but here there'll be like different kinds of things can come into play. So you should be always, ready to learn new technologies. And I would say, like, pairing with people will always give us some kind of additional advantage of, easy to adopt with the new changes. So yeah.
Yeah, back around to people again. Cool. So that's me exhausted all my questions. There's one in the chat, and I shouldn't be surprised really. Is AI going to take everybody's jobs question? Well, not exactly. So the question is, what AI tools are you using to bring benefits to microservice development, and how are they improving productivity? Are they delighting or disappointing you? So I guess, Chris, you kind of touched on AI tracking down problems through your log.
Yeah, in sort of its largest ways form, certainly sort of the correlation of incident events and proactively trying to determine failure based on failure happening previously. So yeah, certainly in that space, I know some of the teams are also using the Copilot style tools in GitHub as well. Working with the larger platforms like ServiceNow, those plugins are really, really helpful, and driving those sort of integrations forward at speed is really useful. I mean, we're also using AI more in the products that we're developing themselves. The language, translations done by the sort of the AI tools, the sort of the summarization components really useful that augment a service product, for example. Really great. So there's the advantages as well as risks. I mean, I guess the thing always with AI is you need to know what you want to ask. So there's still always going to be a level of it's the same with Google query, right? You need to understand the context of what it is you're asking and be able to do that well to get the responses back that are useful. Certainly at this stage, anyway.
Yes. And anybody else thoughts on AI?
Well, I mean, similarly, I think ChatGPT or Copilot, they seem to be fairly prevalent these days. Certainly, we seem to be using them quite a lot in their forwards. I think it's about structuring the question exactly what Chris has said. It's the weird thing is it's not that different from computer programming. Like you have to define the problem properly in order to get the correct answer from the computer, whether that's AI or coding. And I definitely think they can help.
So even from the testing perspective, there are tools which are like adapted into the testing environments. Like self-healing is one thing. If there's some element has been changed, now there is new AI tools where it can come and self-heal. It understand, okay, this is what has been changed and this is what expected, and it automatically heals the test. So the failing is also reduced significantly now.
Mm.
Yeah, just to expand that a bit, we mentioned ChatGPT. I mean, Copilot, but with ChatGPT, with generative AI in general, you can it can help with so many things like documentation or even finding the right name of your entities and variables. I don't know the name. Yeah, maybe quite useful.
Yeah, it's great for boilerplate and I find stuff like testing that are supposed to be simple but really tedious to write simple tests. Whereas if you've got an AI companion pair programmer, isn't it? I think it's seen somewhere that's like having a pair programmer. You kind of write a comment about what you want to test, and it goes, "Here, do you mean this?" And it didn't. Well, not quite that. That's close enough, and I can knock it around a bit and make it do what I really wanted.
Yeah. That's right. And Copilot's particularly good if you have a question about Microsoft documentation as well, because it knows all of that.
Cool. So I guess we've got no more Q&As in the thing. Last chance if you type it quick before I run out of steam, you might be able to sneak one in. So I've just got a few notes. I'm just gonna see if I can skim through and do some kind of summary from them. So we kind of touched on coupling, that microservice distributed architecture can help you decouple, but can also still be coupled, and you might not know it until it's too late. Ownership, Conway, teams. Yeah, that's that. If you've got one thing, it's hard to have that kind of ownership when everybody owns it, nobody owns it. If you ask two people to water a horse, it'll die of thirst. So there's that in there. What else we got? Size and risk, logs. Yeah, I think logs is a massive thing. I only discovered recently that how massive in terms of the AWS build it is. As you start building more things, you need more logs, then you have to store that data somewhere and process it and handle it. And if you're not careful, you can kind of run up big, expensive bills just by logging all the things. And I'm sure there's lots of other, because you get a little bit of overhead with every bit of the services. The more you have, the more pods you have, the more functions you have, the more of those little extra costs that come with them. So I guess costs and other thing. Automation, yeah, loads of automation empowerment. You build it, you ship it, you run it. You can't really do that with a monolith again. It's who owns it when everybody owns it, nobody owns it. Simplify things, serverless. So that's my rambling summary. It makes sense in my head. Hopefully it kind of triggered some thoughts with everybody else that's kind of been watching. I guess the final thing to say is thank you to everybody that joined the discussion. John, Didier, Chris and Gary. Thanks to everybody that's been watching us. I hope you kind of learned something new, or if you haven't learned something new, at least you know that you're not alone and other people are facing the same problems that you're facing. And thanks to the tech team and the marketing team for supporting this out. And hope you use microservices, serverless, distributed architecture to its advantage, and find the path through the pitfalls for it. Thank you.
Thank you, Andy.
Thanks, Andy. Thanks, everyone.
Thank you.
Cheers.